Yo, 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 what's up? It's your boy Dappa from Coding with Dappa. Hey, you know, it's Dappa Star TV, and I have to go look at what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that what's going on with my channel. Want to make sure that oh, when I type in Twitch Dappa Star TV, my name does not come up. I don't understand what's going on. It only comes up on my YouTube, which is very funny because I put my Twitch videos to my YouTube. Okay, how do I get Twitch to search? I want to make sure that you guys are hearing me, because somebody actually reached out and said, Gio, your last video did not have any sound, and I felt so nice because somebody watched my video. Can you imagine somebody watching a video that you put your blood, sweat and tears into?
Blood, sweat and tears.
The good thing about Twitch is that there is no effort. Just live stream and come on. Everybody you can see Kevin right in the background. 1 2. 1 2. Nice. 1 2. Talk.
1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2.
Yes, my peeps. We're gonna be doing some neat code today because we're neat with the code. Best believe it. You never see it. Alright, today we have so basically actually just making sure I can hear what I go on here.
What was the time complexity of going through the entire linked list? Well, it was the same as doing so with an array. It was big O of n, where n is the size of our linked list. So far, we've learned that linked lists are pretty similar to arrays. Let's talk about a few.
Okay, for some reason there is no audio out coming out of my computer because, well, I have this charger but it's not charging. So let me just borrow this. I have this JBL speaker but it is not charging. So my audio out keep going out and I don't want to use a headphone. Okay, so you know last time we did reverse linked list and merge two sorted array. Today we're gonna be doing doubly linked list. Yay! So what's a double linked list? A linked list is when you point, you know, you have a address in location or address in memory, a location in memory, and instead of having, you know, the memory actually being contiguous, you have the value and a pointer that points to the next value. With a double linked list, you have the pointer pointing to the previous and the next value. So this is how the list node looks, and this is the code for how to code up the implementation of a double linked list. So here what this guy did is, you know, self that head, this node to a dummy value, make the next of the head be the tail, and make the previous of the tail be the head. And to insert to the front, it's a new node, list node, and then new node that previous is equal to the self that head. What does that mean? You create a new node and you point that new node's previous to the head, and then you make that new node's next be self dot head dot next. Interesting. So they do it in a way that you're actually ignoring the value that you passed. You know, not previous. You know me, I'm a whiteboard. So I'm gonna pull up my little whiteboard, you know, my friend. Me have to pull it up, pull it up. Now me make it up. Me have to pull up my whiteboard. Kind of boy can't this thing. So you're inserting 6 at the front. So a new node, you create a new node. What's that value to divide on here? Make new node dot previous point to head. So it points to this little command here. And then let me do it in this way. So since we know that's new node that previous points to head, what's happening? New node that previous points to head, and the new node that next points to self dot head dot next. Okay. And then self dot head dot next dot previous is equal to the new node. Self dot name dot next. What the? Oh, I get it. I see. So this is a dummy node. So we'll always keep the head as the dummy node, I guess. So if you want to insert something to the front, it's going to be behind the head that you created. So a very interesting way of doing it. Insert to the end. Let me see if it's the same thing. So new node, inserting a value called 7. New node at next, point to tail. And then new node that prev, point to prev, self that tail, that previous, that next. So that previous, that next, point to this node, got it? And then self that tail, that previous, points to here. So this is the previous and this is the next. So that's how you add to it. So whenever you have an array, you always have a dummy node, dummy node. If you're inserting 6, you're going to point this to this, this to that, and then make sure that points to that, and this points to this. And the same thing happens here. 1, 2, 3, 4. One that's going out, one that's coming in, one that's going out, one that's coming in. I think they did this because in order to remove from the front, you just use the current head and point it to next dot next, and then make the next pointer previous point to the head. Next, that previous point to serve that head, and then serve that head, that next point to serve that head, that next. Okay, Tiki, you get it right. Now remove end, same concept. Print current equals self that head that next. While current is not tail, print the current value. I got it. Did that make sense to me? So let's try a question. So I haven't done this question yet. Design an implementation of linked list. You can choose to do a singly or a doubly linked list. Yay! Woo! A node in a single linked list should have two values, val and next. So I'm going to just do that up quickly. Value and next. So val equal val, or self dot val, because it's a member of that class. Self dot val equal val, and self dot next equal next. And we're gonna pass in next equal none, and val as the original value. So val is the current node, next is the pointer to the next node. I don't know why this is highlighting, but let's interesting. So implement my linked list, initializing the my linked list object. So you're gonna have a head and you're gonna have a tail. Just like I like the puppy, but that puppy also has a head instead of just a tail. But some puppies just have a tail. So if I do this dummy approach, why would I need to do it? I need to do it as, so I can just have one. It's gonna be a -1, and the next pointer I guess it's only necessary to have both dummies when you want to have a way to remove from the head. When instead of that you want to have one. What happened here? One dummy at the front, and then point that, make the tail point to the dummy at the front. So how many pieces?
Two dummies and you're dummy at the front.
You're so funny. So get that index, add that head, add that tail, add that index, delete that index. So it says get the value of the index node in the linked list. If the index is invalid, return -1. So in a normal case, you have an array, a linked list, 1, 2, 3. So you have 3 cases. You have one where the index is outside the range of the current array, so 0, 1, 2. Index come here. We'll be traversing the array, and if the current dot next is none or null, then the index isn't available, just -1. If it is here, if you want 2, 0, 1, 2, it's inside, and then if it is empty, so meaning we just have the dummy array, then the 0th index is going to be -1 because there is only one element. So this is case 3, this is case 2, which works. Return 3. And this is the case 1, which is out of bounds. Alright, so let's see what happens. So since we initialize a variable already, what happens when you ask for get? So I have a -1 node and it doesn't point to anything. You know what, let me do add at head and add at tail first, so that we can actually walk through and like test stuff. So return -1, you're gonna always get return -1 for now, and then for the add at head, we'll create a new node of the value that you passed in. So D is here, add at head, create a new node, and you want so basically, if it is if you can tell that is only the head of the list that is currently there, then you want to add that to the head. And then if it was a case where you already had a element, you want something to add at the real head or at the front. So you have a new node, and you have it as 1. So let's create a new node. Well, it's there already. Well, you need access. So you want to make sure that the new node So self.head dot next is equal to new node dot next, and then you say self.head dot next is equal to new node. So that is how it is when you add it at the head. Cool. And then at the tail, because I never use the other dummy and we don't have a previous pointer, we have to iterate through the array, through the linked list when we are trying to add at the tail. Oops. Alt and S. So you want to add a new node. So if you added something to, so I want to have the same condition here. So if self.head.next is not equal to anything, then self.head.next equal new node, and then else you create a new node. You have the new node already, so let's say it's 4, and what we want to do is traverse so while current is not null, actually you probably want to do current.next is not null, or you have a previous as well. Or 2 point, like, so there's two ways to traverse that keeps track of the previous pointer. So like if you have a current here and you want to make sure that you still have access to what was current before, what you could do is keep track by having the P right before. So when you go to current.next and then current isn't or is null, then you still have P. But you also could just say while the current.next is not null, increment current. So when current.next, so when you reach to current here, current.next is present, come back here, current.next is not present, so you stop, then you say current.next should be the new node. So but the only thing about this is like, okay, so you say current.next, okay, so in current.next is now, so C, then you update current.next to be equal to the new node. So that's how we add that table. Let's see what happens. So we have a couple test cases passing, which is good. My linked list, add head, add tail, add index, get, delete index, and get. Well, it doesn't matter that they're passing now, because since it's being tested in this way, let me see if there's any other. How did they do the test cases? Interesting, I don't know. I guess I could add a test case, right? Can I? Wait, aren't you supposed to pass in a value? What's happening, South? Oh, I see. Self dot head dot next dot value. How can I see this thing? Oh, can I see the result of this test case? I want to run this test case and see the result for this. Use test case. Nice! Boom, 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 boom. Cool. And then add that. Maybe if I do add a tail. Ah. So in order to get the get of like 1 or 2, so let's say 2 on indexes 2, 0, 1 or 0, 1. So if you want 0, you should be getting this value. If you want 1, you should be getting the second value, which is 2. So we can start at self.head.next. If self.head.next does not exist, then we already know return -1. Yeah, so we can take that away. If the index is 0 and there's a value here, we start off current at self.head.next equals 0, current node equals self.head.next, and then we say I and current self.head.next while I is less than index, cur then I plus equal 1, and then so let's say C I equals 0, and then C x I equal 1, and 1 was passed in. Then I would be equal 1 here. From the previous cycle, what you want to do is just return Okay, let's try this. What happens here? 66 plus. And that index will probably be very similar to this, so let me get some. Okay, so I have a new node equal this node if self.head and next, or if not self.head.next, then we just put self.head.next equal new node. This is an edge case, but if it's equal to 1, if it is greater than 1, so if index equal 1, we're just going to return if it's not equal 1, sorry, if it's equal 0, right? Else, so if it is greater than or less than 0, I guess, whatever, then we do nothing. I believe you can just return statement straight. Interesting. Yeah, I guess I can just do it in one. So, x equals 0. Now, 1 second, guys. While I is less than index, then is there only the index thing that I'm paying attention to here? Let me see. So we're adding at the index. So if I add 0, you know, it says already 0. We want to head next. We want to store that value. We want to point this value to this one. No, we're only doing that when you're only doing that when the index, when I is the index. So we just keep iterating first. So we just keep doing this. So like, alright, in the index that it is 0, we create this. So let's talk about that case. When the I is equal to the index. So in this case 0 is equal to 0 is equal to index. So when I is equal to 0. So right now it's 0 in the first one. So current on next, we want to store that. Oh no. Prev equals self the head, maybe, and then we say prev dot next we want to basically we're just storing the value there, and then the new node dot next is equal to or just current, right? So we have current already. So a new node should point to current, and prev dot next should point to new node. And that is only indicates that index is equal to I, right? So in the other case, what we want to do is cur equal cur dot next and prev equal prev dot next. But we want to make sure that one second. We want to make sure that current equal current dot next Wait, Kev, one sec. Previous equal. So you have current and previous. Previous dot next. So current equal current dot next. So current equal current dot next, yep. And then previous equal previous dot next. Yeah, good. And then what you do, I'm also feeling like we have a case that we're missing here. So while I is less than index, which can be true. So like 4, let's say it's 4. But then we don't have another one to go to. So let's say there's no 3 here. So 1, 2. So we have to make sure and car. One second. Baby, you see me now? Alright, so car equal car dot next.
Good night.
Night night.
Kiss kiss. You need to come back and make it. Here.
What is going towards the camera?
Hello, good night, kiss kiss.
Suppose me never want that on my stream. Yeah? Yeah? So while I is equal to index and then oh, so new node that next points to the current. So in this case we have 1 add at head 1, so, and then add at tail 3, and then I'm saying at index 1 0 1, at 2, and then I'm saying at index 1 get 2, delete at index 1, so add here get delete index 1 get. So right now we're seeing in this output that if we are getting before we do the delete, we were asking for something at index 1. So let's see if added index added 2 properly. Maybe just never added the 2 because we're getting 3. It's not getting the 2. So new node, that's 2. If it is not self.head.next, if self.head.next is and index equals 0, then self.head.next equals new node. Else previous is self.head. Let's just initialize previous as self.head.next. And let's initialize current as previous.next. So P and C. So this is how it is at 0. If the index is less than, then and the current exists. I most want to say previous. Yeah, previous. Because you're looking at the current. Yeah. Let's do car and next. index equals 0 here. I mean I equals 0 here, and in this case index equal 1. And I is less than index, and current before we move on to anything, check so if they wanted to add it at 0 here, so I equals 0, if index equal I, so if it was 0 here, then it would be car, so I have that next. Yeah, you need to have an element. Damn. So what's 0 there? You wanted index. So going back to the original plan, oh my gosh. So in this case that this is not equal, so cur previous equal previous, not next. And current equal current, that next. And then I plus equal 1. So now C is going to be here, and P is going to be here, and then I is going to be equal to 1. So P and C, if it isn't, so it is not equal, I is not less than index, and car is present, so we see we can go, but it is not going to go inside the loop because I is no longer less than index, because 1 and 1 is not less than 1. So if index equal 1, new node dot next equal the current, and then previous index equal this. Okay, so in the event that index was actually 2, 0, 1, 2, 2, if index equal to, so if it got to that end, then okay. Interesting. But if then index is not equal to I, so let's say it did another one. Okay, in this case, you know, if index is equal to 2 and this here did not, here it met this condition cure, it's going to try one more time. Cure is going to be nothing, and then previous is going to be this 3. So what will happen is that because I equal I plus 1 here, index I is going to actually be 2, new node dot next is going to be pointing to current, which is nothing, and then previous dot next is going to be pointing to the new node. Previous is here. But in another case now, where it actually got to the stage where I is not less than index, or I is 1. Well, is there a case that you can even get I is less than index and cure? Yes, sir. Well, at least we got it here for the get at that index. The get is now passing. Now we need to delete that index properly. And then we should start seeing more cases pass. So if the current do nothing, I guess. So So if you want to delete something here, you just point this to this. So this is gonna be P, this is gonna be P, this is gonna be P, this is gonna be C. Current.next, and then current.next, you want P to point to current.next, and that's it. Yeah. So if 0 equals 0, then you have nothing to do here. Current equal index, if current equal index, then prev dot next is equal to prev dot next. Or I guess you can use a prev equal to current dot next. Okay. While current index is less than index prev current prev equal to prev dot next. So let's say 1012 starts here 0, current is here, P is there, index is 0, and then I equals 0, 1, 2, so P is here, C is here, I equal 1. Still less than 0. C, P, equal to I is no longer less than that, so if current equal index prev dot next equal to current dot next. Return. Wait, why is this curve? Okay, come again. If index is equal to index, so I equal to index is equal to 2. anchor. Then delete. But if car did not exist, next equal to equal to 012 current previous dot next to previous dot next, but there's no dot next here. Okay, sure. So the next thing that we want to do then is try to shop these. Oh wow, 25 out of 66, that's a lot. So what happening? Let's see. So add that head and I get. So if we have a linked list and we add 4 to it, add a head, and then we say get 1 no, then this should say -1. So if not self dot head dot next, so current equals self dot head dot next. So C is here, I is equal to 0, while I is less than index, and car equal current dot next. So car becomes C and I becomes plus equal 1. Suppose so if I equal index and not car, return -1, else if car and I equal index. Okay, so if I equal index and not car, can I just say else then? If index and car else -1. Boom! 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 How many just kick backside wall. That's crazy. Yeah, okay, I guess I implemented the linked list fully. I guess a lot of people started using the double linked list. But let's read through this here. Let me start another stream. That was cool. Took a while, but that's what this is about. Um getting reacquainted with all these concepts and stuff. I used to kind of just hit this out quickly, but now I have to think through things a little bit more and work at the same time. As you can see, I'm using my whiteboard here. Has been very helpful. So if you have an interview, that's a good opportunity to do it. One of the things that I would try to do better was talk loud up more at the start of my thought process. I'll go through the scenarios a little bit before starting to code, but honestly, sometimes when it comes to data structures, specifically like queues, etc., linked lists, arrays, it's good to just like draw out each of the cases and then coding each of them, starting with the edge, or starting with either the edge cases or starting with the happy path. Sometimes I like to do the edge case first to get it out of the way. Like, so okay, if this was empty, then clearly this is what I would do. If this was out of bounds, that's clearly what I would do, and then I do the happy path. Oh, wow. Let me see if anybody's saying anything. I doubt it, but maybe in the future you all will. Okay, no, that's it. Yeah, let me stop and come back.